Lecture 5, the Multiple Linear Regression Model. Now in this lecture, we're going to extend what we learned in Lecture 4 on the linear model to settings in which we have multiple independent variables or covariates. And actually going forward in this course, for all of the models we're going to develop from this point forward, we're no longer going to restrict them to just having one single independent variable. We're going to allow for multiple covariates. So this is a lecture on the linear regression model, but it also sets the foundations for other models that we'll cover going forward, where we allow for X to have multiple elements. The lecture is split into 6 parts. I'll first cover the learning outcomes. I'll then talk about the issue of how we interpret parameters in a multiple linear regression setting, that is, in a model in which we're looking simultaneously at the influence of multiple independent variables on a single dependent variable. I'll then cover the relevant statistical theory, so we'll look at the mathematical and statistical properties of the least squares estimator in the multiple linear regression setting, and we'll do this using matrix algebra. That again is an innovation in this lecture relative to previous ones, and matrix algebra, I hope you will find, considerably simplifies the calculations. Okay, in section 5.4, I will introduce an alternative interpretation of least squares, that is to look at it geometrically, which offers a useful alternative perspective. And then in section 5.5, I'm going to turn to application. So we'll look at execution of the multiple linear regression model in R, and we'll look at it for both the purpose of both inference and prediction. And then in the final part of the lecture, I will summarize what we have learned. So in terms of learning outcomes, after viewing this lecture, I want you to be able to represent the multiple linear regression model using matrix algebra. As I said, matrix notation is important because we're going to use it going forward in this course, and because it makes things nice and simple. I want you to understand how to interpret parameters from a multiple linear regression model. The idea being that a parameter in an MLR model, that is multiple linear regression model, is essentially telling us how one variable, one independent variable, affects the dependent variable holding other independent variables constant. We'll make that point. That's an important point of interpretation that I'll explain in the lecture. I want you to be able to derive the least square solution for the multiple linear regression model using multivariate calculus. And I want you to be able to show that the least squares estimation of the multiple linear regression model is the best linear unbiased estimator, so-called BLUE, the best we can obtain under the Gauss-Markov theorem. As I said, we will look at a representation of the least squares estimator geometrically as an orthogonal projection, and I want you to be able to represent this concept graphically and using matrix algebra. I want you to be able to demonstrate equivalence between solutions obtained via the geometric interpretation, that is orthogonality of the error vector, and via minimization of the residual sum of the squares, that is using multivariate calculus in the way that we did last week and in the way that we'll do in just a minute for the multiple linear regression model. And finally, I want you to be able to execute multiple linear regression in a statistical software R for the purposes of both inference and prediction, and I want you to be able to interpret the results.